Hello, let's look at some examples of oblique triangles. All right, so here is our first example, and let's use what we already know about triangles to maybe help us find it. So first of all, we know that the area of a triangle is equal to 1/2 base times the height. Well, we don't have a base and we don't have a height because this is not a right triangle, but we can maybe possibly, let's say if we draw a straight line here. Well, if we draw a straight line right there, and I can easily see this because I can see the triangle, then this will give me the height. Well, I don't know what this is, but I can use my laws that I have to find out what it is. So let's use our laws that we have. So I have this measurement here. So I can say the sine of 90 is right across from the 7.8 is equal to, and I want to find this height here, the sine of 74 over, let's call this h for height. H for height. Well, we already know that the sine of 90 is 1. So 1 times sine of 90, if I do my cross multiplication, just gives me h. So h is equal to 7.8 times sine of 74. We can solve that out, or we can leave it like this. I'm going to solve it out and leave it like that because I want to eventually show you how these things are related, okay? So if I go ahead and solve it out, I get 7.4978. And of course, this is in meters. Okay, so now I have the height. I still need the base. So let's find the base. So again, we'll use what we have, which is sine 90 over 7.8 is equal to, I cut this angle right here in half. So instead of being a full 32, it's half of that, which is now 16. So that's going to give me sine 16 over, so sine 16 is equal to this part right here. So that would be, we'll call this x. So it's not the whole thing, this is just half of it, right? So x. So again, sine 90 is 1. So when I cross multiply, I just get that plain old x. So x is equal to 7.8 times the sine of 16. All right, so if I solve that out, I didn't write that one down. Let me go ahead and do it really quick. It's 2.15. So I'm going to write out more decimal places though, just because I want to be as precise as possible. Remember, you can use Desmos to calculate. Make sure your calculator is in degrees. All right, so now again, I have 1/2 base times height. However, this is just half of my base, right? So I need 2 of these. So when I put this in my formula, I get 1/2, and actually I should have named this B, right? Let's call it B because it's our base. And actually it's just half of our base. So area is equal to 1/2 my base. So this is going to be 2 times B. I'm going to put B here. And then my H. Okay. So that gives me area is equal to 1/2 so if I multiply that by 2, I get 4.299, 4.2999, so on and so forth. And my height is 7.497 ... So my area when I multiply all of that out, is 16.1 meters squared. Okay, so this is just one way of doing it. As you can see, it's pretty long and complicated. Well, if we don't have this, we have two formulas that we can use, and it says that if we have two angles and a side is given, then we can use this formula. And if we have two angles and their included angle, we can use this formula. Okay, so let's apply that to that triangle that we just did. So this is the exact same triangle that we did, and let's use the first formula for two angles and a side. All right, so we have two angles and a side that's given here. We can find out what this other angle is because the total amount in my triangle has to equal 180. So that means that this has to be 74. So 32 plus 74 plus 74 gives me 180. So then going back to that formula, so my formula is what I have here. So we are going to use the exact same letters that they have here. So my A would have to be the side that I have across from that angle A. So we'll use that. So we'll have area is equal to 7.8 squared times the sine of 32. Actually, my B is 74. So we'll use the exact same values, although it doesn't matter. I hope you understand that. Sine, doesn't matter which one I actually put first. But it does matter which one is my A, right? So that's sine of 74. Notice that my sine of 74, I got one up top and the bottom. I can cross these out because they're exact same, okay? So I don't want to do extra work. So that's going to give me 8.2 squared times sine 32 divided by 2. And when I evaluate that in my calculator, guess what I get? So 16.1, and I know this is meters squared. Similarly over here, when I worked it out, remember my height was, so that is 1/2. My height is 7.1 sine 74. My base was a little different, so that's what makes it a little off, but my base was also 7.8 times sine of 16. It was divided by 2. This one was divided by sine of 74. If you recall, we had to also multiply our base times 2. So that was another 2 right here for our area. And so basically these are going to cross out. I have 7.8 squared. So our area here was 7.8 squared sine 74 times the sine of 16, which basically from the other slide that we just calculated came up to be, I'm running out of time, sine of 32 over 16 times 7.8 squared. And our 7.8 squared is cancelled out, and these two values are equal to each other. I'm sorry I couldn't go into better detail. Now let's use the second formula. Area is equal 1/2 ABC sine C, and we have to do two sides and their included angle. Two angles it says two sides and their included angle are given. All right, so again, we have 32 and 74 as our two angles. We also said that this side angle has to be 74. Well, if this angle is 74, these two are equal, then that means these two side measurements are also equal. So we're able to use that formula of area equals 1/2 side AB times the sine of the included angle. So our included angle here is actually at C, so we're lucky again. So we have area of 1/2 of 7.8, basically squared again, is equal to the sine of 32. This should look similar to the other ones that we've done so far. And so again, when I evaluate this, I get 16.1 meters squared. All right, let's take a look at another one. So I don't have a triangle, so I'm going to draw one out just to help me to visualize. So B is 13 centimeters, C is 11 centimeters, and A is 5 centimeters. So I need to find an angle. So I'm going to find, because I need at least one angle. So I can do that. I can use my law of cosine. So I'm going to do 13 squared is equal to 11 squared plus 5 squared minus 2 times 11 times 5 times cosine B. And that's just my law of cosine. All right, so I need to evaluate. I'm sorry, again, for the sake of time, we have b squared equals a squared plus c squared minus 2ac. Cosine B is my formula for law of cosines. And so I went ahead and evaluated. I got 169 equals 121 plus 25 minus 110 cosine B. I combined my like terms. 169 equals 146 minus 110 cosine B. Subtract the 146 from both sides. I got 23 equals negative 110 cosine B divided by negative 110 on both sides. I got negative 209.0909.091 equals cosine B. And I just do that for accuracy. I took the cosine inverse of negative 2.09090991, and I got B is equal to 102. So now I can apply the formula. Area equals 1/2 AB sine C. This time I'm using different lettering though. So it'll be 1/2 times 11 times 5, because those are the angles on the the sides across from my B, and then sine of 102. I'm going to plug that into my calculator, and when I do, I get the area is equal to 26.9 centimeters squared. Let's see if I have time for one more. All right, I have I'm going to go ahead and draw it out to help me visualize what's going on. So A, B, C. A is 24, C is 137. Oops. B is 4 centimeters. I can easily find the angle B. Angle B is equal to 19. So I have two angles in the side, so, and an included side. I'm using the formula. Area is equal to my side squared times the sine of 24 times the sine of 137 all over 2 times the sine of that angle that I have the side adjacent from, which is 19, and I get the area is equal to 6.8 centimeters squared. And I hope that this helps.